SDN seems to be a pretty big buzzword these days in the world of networking. And in this nugget, I'd like to introduce you to the concept, the idea, if you will, of software defined networking that is supported in Windows Server 2016. When I think about software defined networking, I'm reminded of the cartoon character George Jetson. Now, his job at Spacely Sprockets was to, I don't know if you remember, it was to push the button. That's all he did at his job. And ideally, in a network scenario, if we had a button that we could press and then magically everything would happen behind the scenes, that would be fantastic. And one of the promises of software defined networking is that we can manage our network environments dynamically using a cloud based type of architecture. And a big part of that is virtualizing almost everything. For example, if we have a physical network that we're using for moving traffic back and forth, in the past we'd use things like VLANs to quarantine a group of devices and put them in the same layer 2 broadcast domain. But if we virtualize the network, we no longer have to create VLANs to isolate computers. For example, if we wanted this computer right here, VM1, to be on the same subnet as VM2, but yet we wanted them not to be able to talk to each other, we could define that policy and then allow the network to enforce that policy so that these two virtual machines would never be able to see each other's traffic. Or if we wanted, for example, VM3 and VM5 and 6 to all be logically on the same network, we could do that as well, even though those VMs are being hosted on physically different hosts. And if we had security policies in place that we wanted to enforce, we could enforce those, and even as virtual machines move in our environment, we could consistently maintain that policy. For example, a firewall policy, regardless of where the VM moves, because again, it's all been virtualized. So with software-defined networking, we're separating or abstracting the apps and the workloads from the actual physical resources being used to deliver those workloads. And again, the benefit is we can, through software, define our rules, define our segmentation, define our policies, without having to always remember all the physical details of our network. Now, in order to have software-defined networking, we have to have some physical resources in place. For example, we need some physical networks somewhere that are actually moving traffic, moving packets. And we also need to have some physical hosts somewhere. For example, running Hyper-V, which are providing our virtualization for the Hyper-V network virtualization and for the virtual machines that are running on those hosts. And besides having the physical networks and the physical hosts to support the infrastructure, we also need to have some central point of contact that's keeping track of and effectively controlling all of it. And we refer to that device, to that object, as a network controller, which is now one of the roles that we can add as part of Windows Server 2016. And here's the basic concept of how it works. We'll have a user, for example, let's say Bob is going to be the manager of the network. So Bob sits at his management workstation. So in the past, Bob would directly connect to things like routers and switches and hosts to make configuration changes. But with SDN software-defined networking, that's no longer the case. Now what Bob's going to do, Bob is going to communicate with the network controller. So if Bob needs information, he gets it from the network controller. If Bob needs to push configuration or changes to the network, that's going to be done by Bob communicating with the network controller, and then the network controller in turn will communicate with the infrastructure, the physical devices, the host, the logical devices. And that's the separation point, if you will, between the workstation component and the rest of the network that's being managed by software-defined networking. And the question may come up, well, what exactly can the network controller interact with or operate with? Well, it can operate with Hyper-V virtual machines and virtual switches. It can interoperate with the data center firewall feature. It can interact with remote access server multi-tenant gateways, virtual gateways, and gateway pools. It can interoperate with the software load balancer that we covered in a previous nugget, and much, much more. So the communication between the management workstation and the network controller are done through something referred to as northbound APIs. Just the way we interface with the network controller. So if we put Bob's workstation up here on top, in fact, let me redraw it. That way the north-south band will make sense. That will give you a visual representation of the relationship. So northbound APIs are between the management workstation and the controller itself, right here. And the northbound APIs, if you will, the communication between the management workstation and the network controller allows us to configure, monitor, troubleshoot, and deploy new devices on the network by making those requests back and forth between the workstation and the network controller. We can kind of think of the network controller as the middleman between our management station and the rest of the network. And some of the tools that we might use, for example, Bob might use as he interacts with the network controller, would be things like PowerShell. There's the REST API and applications that go ahead and use the REST API to interact between the management workstation and the controller. REST, by the way, is an acronym that stands for Representational State Transfer. It's a very common API. And other tools that Bob might be using up here include System Center, Virtual Machine Manager, and other similar tools that can interact between the management station and the network controller. So these are all examples of northbound APIs. Now, if Bob is interacting with the network controller, of course, the network controller would also need to go ahead and interact with the rest of our network devices in order to discover devices on the network, detect configuration of existing services on the network. It could collect data, collect information from those devices on the network. And when changes are being requested by the management workstation, it would also involve pushing configuration to those devices to change the network. So the mechanisms used to communicate between the controller and the network devices themselves would be examples of southbound APIs. And again, one of the big benefits of using software-defined networking is that we can configure, for example, a firewall policy or a security policy for one of our devices or a group of devices. And then as a device, for example, is moved from one host to another, the network controller could enforce that same policy on that VM even as it moves. And one of the tricks that we have with Hyper-V network virtualization that allows a VM, for example, VM3 on one host, to be in the same logical network as VMs on another physical host is by using encapsulation. So as traffic from VM3, for example, goes over to VM5, what happens is the Hyper-V hosts are going to set up tunnels and do tunneling between the two. So I'll have this red line here represent one or more tunnels. So that if VM3 needs to forward a packet to VM5, for example, VM3 would send the packet. The Hyper-V host would go ahead and tunnel that packet, forward it over to Hyper-V host number 2, who would then de-encapsulate it and forward it on to its correct destination. So logically, VM3 and VM5 could look and feel like they're next door neighbors with each other on the same logical network, even if they're being hosted on two physically separate Windows Server 2016 hosts running Hyper-V. And there's a couple of different ways that encapsulation can happen. One way of doing that is use the Hyper-V Network Virtualization GRE, which is an acronym for Generic Routing Encapsulation. And similar to many of the other tunneling technologies we've talked about prior in this course, most of which dealt with 6-to-4 transition, basically we're taking the original packet, re-encapsulating it to shoot it over to the other peer, the other host in this case, who then de-encapsulates it to forward the original packet to its intended destination. And with GRE, we're using generic routing encapsulation to do that. However, a more popular and now the default method with Windows Server 2016 for forwarding that traffic between two VMs on two different physical hosts is to use HNV, that's the Hyper-V Network Virtualization, with VXLAN. So instead of using generic routing encapsulation, VXLAN actually encapsulates it within UDP port 4789 as the transport protocol for the tunneling between the two hosts that are the homes for the two VMs involved with the traffic flow. And we're going to find VXLAN being the primary tunneling technology that's used in most current SDN solutions, where traffic has to go between two physical hosts to forward the traffic on behalf of VMs running on those hosts. And VXLAN, just like many other features in Software-Defined Networking version 2, require that the network controller role be installed on the Windows 2016 server. Another important note is that if we need access, for example, let's say this is our data center and we don't have global access to our data center, we could implement gateways, as we've talked about previously in this course. For example, we could do a site-to-site gateway or a remote access gateway to provide the access into our data center environment. And then once the customer hits our data center environment, if we had multiple resources, we could use a software load balancer to distribute the customer's request to one of our servers that's supporting the application that the customer is after. And again, some of the benefits of software-defined networking once it's in place is we can have isolation of virtual machines even if they're on the same physical networks. We can separate the apps and the workloads from the actual physical resources so that we can focus on the functionality and let the network controller actually put all the pieces in place. And some of those pieces that the network controller could implement would be enforcing the policy on things like VMs, even as those VMs are being moved from one physical host to another. Hey, I'm glad you joined me for this nugget. I hope this has been informative for you, and I'd like to thank you for viewing.